Do, do, do. Just waiting for YouTube. Hello, everybody. Good evening. It's Alex, and we're back because I actually have some time this evening. Working on the game on Escape Velocity, our fun handmade style game. Currently, or for the last week or so, we've been working on the Mac port of it. I was a little optimistic. Was hoping to be more done by now, but I think my my internal clock that judges how long programming tasks would take is really calculated around an actual 8-hour workday. And when you only get to really work on the thing in bits and pieces of your spare time, it takes a little bit longer in terms of calendar days. But we're well on our way. If you'd like to join me for this fun evening working session here, all you need is your favorite drink of choice. I've got my Silver Needle white tea, which is, I believe, one of the 10 famous teas. Ooh, very, very famous, very delicious indeed. And we're going to have a sip. Not the first one of the day, but certainly not the last. Okay, alright, so we're in here. We've been going through and trying to figure out a bunch of fun stuff going on with creating the Mac port of the game here. So far, it's been kind of a mess of many of the assumptions that were made for doing the Windows version of the game have turned out to be basically entirely wrong on Mac here. And the latest of those is is one that is another little bit of one that's a bit of a problem. So in Direct3D, you have this concept directly in the API of a swap chain, and essentially what a swap chain is when you are drawing to the screen, you have like a buffer of vertexes that have all the data you would need to we've got them right here, all the data you would need to place them on the screen, to color them, sample from your texture, whatever crap you would want. And if you are trying to draw stuff to the screen, like basically your loop of the game is taking in I/O or taking in input from the computer, like keyboard, all that stuff, updating your game state, and then using that updated game state to figure out where to draw stuff on the screen and send that out over to your graphics processor, right? So that handoff where you're generally involves you creating this thing called the vertex buffer, which we have, it's right there. And this vertex buffers is going to be filled up with all of the positions of all your characters, basically anything that is making its way onto the screen. And once that's done, you would send that over to the graphics processor, the graphics card, and then that would do whatever math that it needs to do to figure out the colors of all the pixels on the screen, and then send that over the wire out to your HDMI or DisplayPort output, so that you can actually go see it on the monitor, right? And the problem there is that you are involving more devices than just your CPU, where you don't really have locality, physical locality of where all this is taking place, and these pieces all being decentralized incurs a bunch of cost in transferring data over the wire, right? So we have, if we were to go with a single vertex buffer here, basically every single time we want to draw a frame, which is, would be 60 times a second, for 60 FPS, or on this monitor, this is 180 hertz display, so 180 times a second. 16 with a 60 FPS, you have 16.67 milliseconds to actually do all that work in. And if you are constantly having to wait, it turns out actually sending that stuff over the wire, not once but twice, eats up like a good percentage of your time there, of your time to actually achieve that frame rate. So if you miss that, if you're really serially dependent on all these pieces, moving data into the correct spots, it makes it much harder to achieve that target frame rate, and especially on devices that have worse compute, worse either CPU, clock speed, memory, graphics, or you just have some kind of problem. It makes things all a lot more inconsistent. And then if you want to bump up the graphical fidelity, right? If we very simply just want to be achieving 180 frames per second to be able to work on my super nice fancy monitor, your time drops from 16.67 milliseconds all the way down to 5 milliseconds to do all of the work, to actually do all of your game state updating and then draw it to the screen. And that is a pretty tough target to hit. So what a lot of games and other graphical applications do is they have not just one buffer, but 2, 3, 5, essentially, that they are filling up and then able to so that you can sort of pipeline things out, right? Essentially, on your CPU that has all the game state logic updating on it, you've got one buffer. That gets sent out over the wire. Then the game is working on the next buffer. The one that is now on the GPU is going around doing a bunch of stuff. It sends stuff out to be drawn onto the display, but at that time, it's actually getting the next buffer. And so basically, you've got 3 or so in flight at any given time. And you may end up with some weird synchronization issues, or you have to do things to accommodate for the fact that maybe what you're drawing is a frame or two behind what your game I/O is actually processing. But what it lets you do is effectively parallelize, pipeline out the whole process. You can achieve way higher throughput doing things like this. But obviously it's going to add more complexity to what you're doing. So in Direct3D, they have a built-in concept that lets you take advantage of this design, and it's called the swap chain. And essentially what that boils down to, if we look for swap chain here, is we basically are creating a whole other thing in memory that we have our back buffer. And we got the swap chain and the current vertex buffer. And essentially, if you look, whenever we generate our vertices, if I can find it, we generate all our vertices, send them over the wire, and then basically what we're doing is we're swapping which buffer is active or not. So here we've got a 2-buffer system. One that is basically on getting displayed, and then one that's getting filled up. And Direct3D exposes this and kind of makes it as simple as possible, I think, for you to just kind of have this in here and not to have to worry too much about how it's going. So this is one thing where, hey, it was abstracted away, but maybe now it's actually a problem, because it turns out trying to port the game to Metal, Apple's render API for Mac native stuff, Apple has no concept of a swap chain directly in the Metal API like Direct3D does. So what do you do then? And so the idea is basically the same. We always go back to our friend Ted Bendixson's code. He basically did all of this work to create a multi-platform game engine, handmade style already, and very graciously open source the Mac and Windows versions of that. And basically what Ted ended up doing is implementing that swap chain himself. It's thank you Buttery Y. It's we're a little bit in the weeds here, and we're working on it. This is a very solvable problem. This is a problem every single game engine or graphical program has had to do at the level that we're working at here, at actually talking to the render APIs, at trying to work close to the hardware as possible as it is from your operating system software. But basically, that's kind of like what's going on, and I believe Ted has not just one buffer that he's using, but I think it's three. So I believe it's right here. So I think this thing, the Apple command buffer is, if we can sort of grep around here, this Apple command buffer is a metal command buffer, and this is I believe a basically a list of the commands that we want the GPU to do to draw everything on screen. And we have now a couple of these, right? And this is in auto release pool. This is like a Objective-C concept. Objective-C is a garbage collected language. And what this auto release pool tag here is basically telling the compiler that, as soon as you exit out of this context, so outside of this curly brace we're looking at right here, all of the memory that was and all of the local variables that were created in there can be safely freed, and then we go on to the next thing, right? So we create one of these, like per frame. Basically, we have one that is kind of like the back buffer, and there's a third one. I'm not sure quite the architecture of that, but essentially, everything gets filled up, sent over the wire, and then the oldest one comes out, and you sort of are rotating, cycling between here three buffers in order to help achieve that target frame rate as best as possible. There are a couple of functional things you also get aside from just performance. I believe this is also how you really achieve things like VSync better, vertical sync, because if you do things like, if you only have one buffer, for instance, you run the risk of having a timing issue, essentially, where the display, your display is kind of drawing scan lines basically across your monitor. So it starts from drawing from the top, recoloring all the pixels for the current frame, then works its way toward the bottom. So if you desync from the what the monitor is trying to do, you can get like the vertical tearing, basically, where the top half of the monitor is from the next frame, and the bottom half is from the last frame, and you have like a pretty big problem there. It just looks horrible. It's not great, and so this is also a mitigation for that problem. So all that said, it was a good catch to find out that we had to do that, to figure out that was a problem to solve on top of all the stuff we already knew. Now we just have to go do it, and thankfully, hopefully with the help of our friend Ted here, with our friend Ted's code, we can make some sense of what's going on here. Now rant over, but unfortunately, I don't think we're actually at the level yet, or at that point in the code where we can go implement the swap chain, essentially, the multiple buffers, because we're here in our Mac entry point, and we're just having all sorts of compiling issues right now because things are just not quite right. So let's go look for this, for whatever CA meta layer is. So we will go in Ted's code, CA meta layer is this. So what exactly is it? Is this an actual type? So this is an actual type. Oh, it's from Quartz Core. Oh, interesting. Let's look up what you use this for, because this does seem like it's popping up quite a bit. A core animation layer that Metal can render into, typically displayed on screen. You're using UIKit. Okay. So do we mean that this is an actual layer, I guess, is the question. Like, is this like, you know, is this like a back to front layer of stuff here? I'm not sure. I'm going to guess so. I would hope so. We can try to clue this out here. Oh, whoops. Oops. Don't do that. So who all is using this thing? It kind of looks like there's only ever one of these, and it is getting initted right here. So in game view is what? This is a this is an NS view, right? So we've got an NS view, I think, is essentially like your like a handle into a window, or like some sort of rendering context, right? If that makes sense. So I think what happens is, like, right here, or the NS window basically is getting set to this. So it does look like essentially there's only one of these. It looks like there's only ever one of this thing. But we are going to need to pull in quartz core now at this point, I suppose, to grab this. You know, we could try to, at some point we could try to figure it out and do what it just said of, like, just use NSView directly or MTK to do this, but, you know, let's not get that far in the weeds with the stuff we're not comfortable yet. Okay, and I just want to double check that. I want to double check if quartz core is the only thing. Yeah, that's the only one. So it's not like metal where you have like two different stupid kits you need to link against. All right, so we're cool there. Oh, these should be imports, I think. I'm not quite certain if there's a problem. Import include C. Right. And what is... Oh, so it just auto pragma once, is it? Oh, okay. Well, that's nice. Let's yeah, that is actually very handy. Yeah, well, why not? Why not? We are already pragma oncing that, but I think, yeah, this is kind of like we're in a weird spot because pragma once, I think, is really only in C++ syntax, and this is only really Objective-C, and we're kind of just like living in this very fuzzy area in between where the Apple version of the Clang compiler just happens to work here. But, you know, we'll live with that. We'll just let it continue working. All right, so I hope, you know, we've got, I think, a couple hours here. We've got until the Sox lose tonight, so let's try to at least get this whole entry point compiling again. I think that's pretty doable. So I guess the next thing we're gonna need is this render commands, and that's a global of this thing, which is a quite big, right? So this type, we've kind of got a type that is very similar to this, and that is our. We should probably put that in the thing. we have a type that's pretty similar to that in our types header. It's called frame, draw frame. And that has our, or I guess we do have it kind of split up. We have a draw frame, right? That has, that's the area of memory where we're storing, I guess we don't need the C buffer anymore. But we are storing our like quad buffer, sort of, and like some other, like our projection matrix, essentially, that we have to regenerate. That's kind of like our C buffer. And then we have the graphics window here, and then this is more like the OS window owning stuff. Yeah. And so I think that Ted's thing is data type is sort of a split of those two of ours, right? But I think the real thing, there's a couple things we actually have to care about, because they seem a little different, right? So one thing we have to be cautious of, right? And I think this is the biggest sort of architectural change in the rendering, even more than this whole swap chain tangent we went on, and that is that in Direct 3D we've been doing everything immediate context, whereas with Metal we don't have that ability, so we're kind of being forced to create like a command buffer here of things to do, and what I think that's going to mean is, if we look at what a game texture draw command is here, it's got a vmin and vmax, texture ID, alpha, rotation, z layer, texture atlas type. So this is like all the stuff you would want to be passing in to your shaders, right? I don't know what this vmin and vmax are. Just knowing a little bit about the code base here, my guess is that his game is all also like 2D sprite art stuff, and I believe what he does is try to draw basically from back to front all the layers, and then batch the layers as much as possible, batch all those draw calls. So my guess is basically as we go through, a draw command is going to be like our whole, is maybe like one quad per layer, and then these are telling you which indexes in the vertex buffer correspond to that. It's annoying that still is broken. Oh, I suppose not. It's literally just the coordinates of the two vertexes that make up a quad. So that's interesting. And what that means, right, is basically your GPU is very good at drawing triangles mostly. Triangles are very nice for drawing because they are always planar, and they basically can never be degenerate, whereas like if you have, and with that in 2D at least, so you can have like your triangle is like always this, and no matter how you like move a vertex, like the triangle is always going to have the same concavity basically. But if you have 4 vertexes, you could have like one of your vertexes normally they would be like this, like a quad, but then this one, imagine it was like all the way down here, but your computer is still trying to walk them in the same order, and so what you would end up with is a totally like degenerate primitive that it doesn't know how to color in the right order. It doesn't know what the normal of it is supposed to be, right? And so that's why in this type of 2D game, you favor where you're drawing from a sprite sheet like this. Basically, you're always drawing. You still want to be drawing basically quads with textures on them, but in reality they're split up. So you're actually drawing two triangles kind of meshed together all the time. And what this is, is this this basically here is describing a his quad, and actually in a pretty efficient manner. But the limitation you're going to have with only using 2 points to describe the quad, or 2 points and then your a rotation, right, is effectively your quad must always be perfectly rectangular, right? So you have no ability, even if it's rotated this way or that. It's always perfectly rectangular. It's always all the lines are 90 degrees, right, from each other. And that is a little bit of a limitation, right? Because you could imagine like that maybe you would want to deform like very very easily. Like you could imagine like maybe I want to be able to deform my quad a little bit more than that for whatever reason. And I don't think the actual memory saving matters as much. Like I totally understand why you would do it like this. It makes it super simple, and especially Ted's code is all written with the constraint of or with the presupposition of just working in like a 2D tile-based game that is mostly asynchronous, right? It's all turn-based as well. So there's a lot of things that like you really don't have to do. Your renderer and a lot of your decision making can be really constrained down to the simplest possible version. That's kind of what we're seeing right here, right? So that's good to know that that's basically what's happening here, right? And then this call right here, push textured rectangle, is I believe going to be pushing one of these quads into like the current buffer, right? Into that's going to make it its way all the way to the GPU. If that makes any sense to you. So. Yeah, and apparently we could have just read this markdown file. This looked really, really useful to read through. Maybe there would have been less guessing around if Alex had read the documentation here, it seems. Yeah, that's a little interesting. Oh, here we go. Yeah, this is exactly what we want. Transfer instance buffer to GPU. Okay. So, instance call. Each instance is one sprite quad. There is no CPU matrix transformation. See, and that's what we figured out last stream. But unfortunately we have to do a whole ton of that to actually be able to achieve real-time collision and physics. We don't really care about that right now. He is doing this DLL thing with the entry points. Interesting. Why would a quad have degenerate properties in a 2D game? Well, it's like if one of your vertexes is wrong, right? Hello, Kille. We're doing some fun rendering stuff, and we're just trying to get our Mac entry point to compile. Let's do like a quad, or I don't know. But basically it would be degenerate. It would be degenerate if you did something like this. So this is kind of like what our quad actually looks like, and the way the GPU has some special logic in it that tells it if the quad is facing there you go, bro. If the quad is facing like basically toward the screen, toward the camera, or away from the camera. And typically what you do is like the GPU is going to try to walk the vertexes and assume that they're always in counterclockwise order for the triangle, right? So you go like, here would be A, B, C, and then A, C, D, or D, A, C, something like that. And what if you didn't have this as a triangle, as two triangles, and you just had it as four vertexes, so you would walk it A, B, C, D, right? And then that would give you a rectangle that faces that has a normal that faces toward the screen. But if D is, for example, not here, but it's down here for whatever reason, then you've got a degenerate case where walking it counterclockwise does not actually give you the correct normal vector. And then once you have that, there's some like you'll get like backface culling. Your shaders will all not function properly because they're trying to control all the pixels inside the quad. So that's why you do triangles, is they can never be degenerate in this case. But yeah, so we are let's try to get back to drawing this here. So render commands.viewport width. So we just need to have here, I believe this is going to be, we're just looking at it. So this is basically going to be our like draw frame that we own right now. So I think we should just start swapping it out to draw our draw frame wherever we can. But that does mean, let's see, we are going to have to initialize all of our memory. So let's see here. We're going to need to be calling our game init function, because this is all our memory arena management. We're going to erase those calls for now. And I believe this should just work. So let's try that. This is going to go all the way to direct 3D stuff and break. Okay, so that's a little irritating. Okay, well, we'll go back up to the entry point and then try to figure it out from there. So let's just like do a really dumb. We'll just like do it here. So game, or it's mem dot draw frame. Actually, is it draw frame or is it the window? I'm not remembering offhand. It is the graphics window. Okay. Window dot width equals. Okay, there we go. And then we want the the height. Dot frame index equals 1. I'm not sure what that is going to be all about there. We'll figure it out. Does this make any sense? Where do these come from? These are okay, we're grabbing those from the rect there. That's good. I kind of don't think we need to do it like that. We can probably just take over this value right here, and then we don't need to have this other thing. Okay, cool. We should make sure like what kind of type that is. Let's see. CG size. A CG size is 2 CG floats. So I think we are going to want to cast those because our I don't know if there's a problem with fractional fractional like window pixel sizes. I have no idea. But let's just not play around there, and we'll do no. Okay. What is initial? What are we using this initial frame for? Is there any real? Is that like literally just to like put some garbage in it? I'm going to assume so. So, oh well, we'll have one frame of black, nothing. That's fine with me. What is this game name? So that's the window set title. I don't know what this at is. Objective C at string. What does that mean? Is that just the constructor for it? For an NS string? Is an NS string a C string or what though? Let's see. Static plain text Unicode string object. So I guess it is an object. Encodes the Unicode client text string. UTF-16. Okay. Initialized from or written to a C buffer. Okay, that's good. Yep. Let's see. So where are the members of this thing? Like this is not a member. Oh my god, this thing has so many freaking functions. Okay, let's see if we can find it here. I just want to know like what the memory layout of this stupid object is. If you could tell me, the vtable for this thing is gigantic. That's definitely not what we want. Okay, I think I scrolled a little too far. All right. Oh well. Let's not do that. Instead, I think if we can just dump in a C string, right? Then let's just do the one that we want, right? Which is dot title. No. Dot data. No. Event string non-null L value of type uchar. Okay, so then we just need to like cast this to char star, I guess. Or how about like we add it? No, didn't like that. That's annoying. Because fuck. All right, we'll make the stupid NS string. NS string title equals interface type cannot be statically allocated. Cannot initialize to value of blah, blah, blah. Do I need to like make it pass in like an initializer here? Init deprecated. What is there a not deprecated one? That would be nice. Contents of URL. Okay. All right. So I guess this is what we want to do. Equals that's my laundry. Should be all right. Let's see here. How do I do this? It's like, oh god, we have to do some object-oriented funky stuff. Init. Here we go. No, that's not right. Called object type ID. It's not a function or pointer. All right. Oh, you just like copy? Is it really like, what even is that? This is like some whack Objective-C stuff here. Oh my god. Why is it so difficult? Oh my god. Why is it so difficult? Okay. The simplest way to do it is by using the NSStrings class method string with UTF-8 string. Okay. All right. I'll take your word for it. And then we'll do like a string equals, what am I looking at here? This is like all Objective-C, like redonkulous stuff. Dot window title dot data. I'm calling this is the thing here, the field, and then that's what we're passing into it. Expected unqualified ID. Okay, so it did not like that. Will it not like that in here? In the actual compiler, I can't tell because we still have a bunch of stupid missing stuff from Win32, unfortunately. Okay, all right. We'll ask our friend, Mr. ChatGPT. ChatGPT, your time to shine. I have a C string. Make an NS string from it. Okay. Yeah, that's is that not what I just did? Oh, I have to pass the encoding? Or is it because this is like not right? Points to a null terminated UTF-8 string. Oh, that's so annoying. You gotta be kidding me. By length encoding. Okay, well, let's try that. That is kind of ridiculous there, to just use this stupid thing. Like, you gotta be kidding me, right? Like, oh my god, this is some OOP hell here. Like, I have the data, I have it in the format that it's actually going to need, but I had to do like all that just complete nonsense. Well, that's good to know that works, I suppose. So I guess this is some Objective-C fun of like, this is how you would we would do the constructor for this thing, I guess. Okay, well, all right, that's fine. That's fine. What is this? Is this NS color? Oh God, we're gonna have to make an NS color too. Jesus Christ. How do this is like incredibly irritating. I have to make sure in my game init we should be or where is it going to be? Someone is setting the window crap here. So it should be this thing. Let's get rid of, or let's comment that out for now. OS window init. Why is this here? I guess it really doesn't need to be here. This is kind of like a graphics window init now. What is this being used for? Oh, this is used for this. Yeah, that's not. Yeah, we can make that a little bit better. But let's just move this for now into here. Do I have one that's in init? I do. I do. And it should probably let's see. Because we need all this stuff to pass into the thingy, into these fields should all be set before we go do anything else for our platform window stuff. We want to be calling like game init pretty early here. I would think. Okay, these things are not getting used yet, so I'm gonna delete that. The window delegates. So can we run our code before we get to the window, before we like pop open the window and stuff? It should be able to, right? That would be a little silly if we couldn't. And I think it would be nice to like just do this, do that like right after we, like why not? Let's just move all these things so they're kind of happening like right after we init the memory for them. That way, I don't know. It's a little bit. I think it's a little bit more readable like that. Let's see. Is this ever getting used? I don't think so. Oh, whoops. Let's just get rid of that flag. It's not really useful right now. We can always add it back. Let's see. Yeah, these things all are blah. The world one we want to leave empty because we want to do that first time we try to loop anyway, so that we get the right start time, which is fine. And these things will get populated at the start of the loop. This thing should get populated at the start of the loop. This thing, it should be empty right now. Yes. Oh, and we should just dump that one here. Yeah, how about that? Okay, that kind of works for me. What else is this going to need to do? So I think, I think we get rid of that. So that should populate all our window struct stuff we need. We will need to call resize at some point. What is this going to do? This oh, this is just where I was switching to full screen. Wait, what? Is that not a real call? Oh, it's called the DX11 reset. Oh, whoops. Yeah, let's leave that for now. It is occurring to me there's a bug here where the window object size is not really updating ever, which I think would explain why the game has been looking so awful every time I put it in full screen. Cause yeah, I knew it was still trying to render at it was definitely still trying to render at 720p, but I thought that was just because like I had it fixed to 720p. I guess that would be the spot where it was fixed to 720p. Well, that's good to know. So we will have to fix that at some point. Not right now, because it will just continue working right now. So actually, it should be like in here. To do get new size from OS rect. Yeah, we definitely need to do that and put in. We definitely need to do that at some point. Okay, well, so this should at least get us to the point in here where now all of these should have like real values, right? Actually, this is wrong. Can we NS screen, main screen, right? I think what this is doing is actually this is getting like the size of the display, yeah, in Cocoa, which is not what we want. We want to be telling we want to be telling the thing what the size is, right? Yeah. So we should not take that. We don't take that kind of nonsense. Apple telling us what's going on. We're the ones telling Apple what to do. We're we feel in charge. Okay. So we do have the window delegate here. We definitely are going to want to to do something. Mask, borderless. Let's not put that mask on just yet. We can come back to what the style should be later. Should be backing store buffered. What kind of types do we have available here? Backing store retained, non-retained. Oh, have effectively been symptoms of buffered. Oh. Oh, okay. That's kind of silly, I guess. Do we even need to pass that in then, if it's just the default? I guess we do. I guess we do. Oh well. Alright. Let's see. Do we need to care about this, or is do I need to like manage this level thing? I'm gonna let macOS care about that. Oh, we do need to get that clear color, right? So we have to init ns color with my for float vector color. Yep. Okay. Very irritating. You have to do so much nonsense here. Yeah, my code feels so clean right now, guys. So clean. And the awesome thing is that we're gonna have to remake this stupid thing every single time we need to change it, which is just so awesome, so awesome. Okay, here we go. I don't know why Ted has so many capitalized variables. That's all right. Yes. So that's pretty much all of that stuff. So we do need, yeah, we're gonna have to come back to the window delegate of what exactly to do there, because that is more gonna be, excuse me, a little bit more specific. But you know, we're good on all this like stupid metadata here. We'll just pass it in. Oh, actually, you know what we should do? We definitely should make a mask here. Can I just? I really cannot just cast these things to. I can't just like cast any of these types because they are all hidden inside NS objects, aren't they? It's so annoying. Because like what it's literally just a bit field that has like a bunch of enums, and I have to go through this whole freaking constructor to do it. That's ridiculous. Because then it's like I have to remake that every single time I want to change it, and I have to make it right here, even though I already have this memory that has the actual thing that matters. These are the only values in the whole thing that matter. I don't need a whole NS object to store this thing. Oh, that actually is so stupid. There's no reason for that. There is no reason for that at all. Ugh. Oh God. All right. So what is this stupid thing? I'm gonna have to make NS window style mask. Yeah, bitmask enum. Can I just cast it? I have a bit field already. How do I cast to this type? Can't it be a simple util function? It could be, but then I have to write this util function a whole bunch of times. Or I have to write the util function. I don't want to do it until I get to the point where I'm going to change it. It's just like annoying because it's extra work, right? Is an NS options type, which is just an integer type. Okay, thank God. Okay, this one actually is just a thing. Is it a U64 though? All right, let's see if it is just a U64. And where is my style? This one's a U32. Crap. Because this is like the Windows window style type. God damn it. So, come on. Can't win today. Window styles. I think not the class styles. Yeah, this is what is that? There's no way that's a 64-bit. This is a 32-bit. Yeah, that's a 32-bit. So, I guess we could be clever here and in Windows just mask it correctly. Yeah, let's just like do it like this for now, and then we'll make a note of it on Mac. Please mask top and bottom words for Windows with EX style. The please is because I'm so nice to myself, and I really care about my own well-being, and I know that'll tilt me a little less when I see it. Okay, so let's see. I don't know why like my tabbing is going 4 in, but the clanged is only doing 2 for why, like, I guess I just need to shove that. Oh no, it's not in here. It's gonna be in clang format. Alright, whatever, who cares? Okay, I care, but we can't get that sidetracked. we simply cannot get that sidetracked. Okay, style equals mem dot window dot style. Okay, excellent. Okay, that's all that bullshit, and then this one is oh, we actually should just set it to that right now. Then dot window. Oh, okay, that should just work, right? Oh, but look, it's like, oh Jesus. Alright, who cares? Keep moving, keep moving. Gotta keep moving here, boys. Alright. We can play around with that later, right? Why does this need to be so big? This really is a 64-bit? U integer. U integer is not a long or a long. Oh crap! What is a long? many bits is this? Size of long equals 8. Okay. That's a little annoying, right? That that their integer type is not. I can't believe that still is like that. That's a little strange, right? Because you would think like that is that kind of thing would just not be in like the modern API of having like different int lengths, but oh well, I guess. Okay. All right. Oh, actually, it should. We should and equal this, right? Yeah. Yep. In case we do want to dump anything in there, right? So, but this is where we want to keep the actual value. I suppose it doesn't really matter, but we could be setting it somewhere else. We could be setting it like up there, so we should just do it like that. Okay. Let's keep moving. End window with. Okay, cool. And then here we go. Here's the business is actually going in and doing some metal crap. So this has its own style mask, I suppose. And the NS view. Is this something we ever need to care about? Appearance customization. Wired. I don't know. Where was that? Auto resizing mask. I'm going to cause this is like Cause this is also like this is a window style too, but it's not in the NS window, it's in here. That's a little weird that they did it like that. I wonder like am I correct? Like who owns all this style? Why is some of the window style stuff in custom metal view owns the window Chrome, while NS view owns the content area? Okay. Well, this. Yeah, I mean, but like this still owns that resizable style, maybe. Yeah, it does seem like they did some stuff here. I'm going to just leave that and never touch it, is the hope. This clears every. Oh, yes, I did mean to or that actually. Yeah, that's totally right. All right, have a good one, Buttery Y. Thanks for watching at 4 o'clock in the morning your time or whatever, whenever the stream started. That is some I much appreciated. I hope that was an entertaining morning for you. Have a good day. Okay. Let's see. All right. Let's try to not touch that. Okay. So now we have to know what is this. What is Ted's frame index thing here? He's doing. We're always trying to figure out what Ted's doing. Basically, I could get him on the phone. You could call him on Discord, but I feel like we gotta give it the old college try first. Okay, so why frame index? This is used in triple buffering on Apple platforms. So that does sound like we're gonna need that. Current frame index. Current frame index. Divided by modulo k max in-flight buffers, which I think is gonna be 3. No? K max equals 3. So yeah, so it's like purely just switching on it there. I'm a little curious. We can leave that right now, I guess, and then just add it to. We have to add it somewhere. So who do we want to own this piece of memory, or have this in its memory? Probably the draw frame. No, the draw frame's getting blown away. Oh, actually, no. It should live there, right? We'll do. This is just a U8. Frame index. Okay. Let's see. We'll do. Yeah. Window. Actually, we don't need to do that because we are going to. We can handle that some other time. It's going to end it to 0 anyway. Okay, then we have to do this stuff. We may have a little bit of a problem here of it's possible this may be a little wrong with the top banner. So we actually may want to just we may want to just add that to the style right now. Window style mask borderless. Let's full size content view. I think that actually is the one we want, because we don't want like the top banner, because that will get counted against us, I think. And we had this bug actually on Windows of there was like basically what one. I was like assuming that the I was not including like the banner as part of the resolution, and so basically the game just tried to auto shrink the window because it was like these values are not lining up, and so it just like kind of disappeared, which is super annoying. Until it did, the two values did match each other, which was when it was just the banner left. So we don't want that, because it also, like, on the game, like, you want to hide that right now. We can, it'll just make our lives easier. Hopefully this is the style that actually I think it is, and it's not just some nonsense. Okay, so the metal device, yeah, this is like gonna be all some fun stuff, and we can actually move, I guess, some of this into our metal We don't have to do that yet. We'll just leave it here for now, and then later we'll make a function that is like metal in it or something stupid like that. Yep. Okay, and then here we've got some actually setting up the memory for the metal pipeline stuff. So we will have to go now draw upon our direct 3D implementation and try to do some of that stuff, but it'll probably look more like this. I'm gonna go run to the bathroom real quick and brew some tea, and when I return, we will continue on. I think it's doable. I think we're kind of close, actually, to being able to maybe compile our entry point again today. So that would be really nice. So let's hope we get that. And we're back. Okay. So let's see here. Let's see. So yes, we wanted to go make some memory for all of this nonsense. What? Okay. So most of this, I think, is just going to be metal boilerplate. It looks like Ted had some helper functions built out that did a bunch of this junk. So we will have to kind of weave back through that. We'll figure it out. So, this is probably just all boilerplate. I'm going to guess here. And I think we're not going to need that for a little bit. We are probably not going to need this shader for a little bit. Or this one. What is this one? This is the metal view delta. Okay, this is the one we're actually looking for. You don't need that. You don't need that right now. Okay. So cool. All right. So let's see. Oh, and we should bring up our D3D implementation. That will tell us some of the stuff that we might want to do here. For example, like all these are just kind of global in here, which was not the. It's fine, fine. Yeah, the things that like we. Like most of this crap is just getting initted at the very start of time, and it's mostly, I think, like that. Like it's really on the GPU, and it's not changing ever. So the things that really matter is like this immediate context that we blow away. The device gets some stuff done to it, swap chain, RTV. The buffer size does change if you like resize. Yeah. Okay, we're not gonna solve this right now. But let's just remind ourselves of like what's going on here. And like again, look, it's like all the same exact crap. It's basically all the same stuff that we were just doing or just looking at. I'm trying to remember how big the back buffer is actually, though. Where's the V buffer getting made? Oh, here we go. Yeah, times max vertex count. That's what we want it to be. That's what we want it to be. So let's see. So we want size of vertex. What is our vertex called? It's called like draw vertex. No, it's called like render vertex. Fuck, I don't remember. We'll find it. It's just called vertex. that would be. There we go. Vertex times 6. Oh, actually, wait, what? Wait, I'm a little confused here. What am I reading? What is this constructor doing? Size of game texture vertex times 6. This is the layout that's going into the shader. No, it's not, because it only has position and UV, and this is only 1. The map is just like POSIX alloc, right? I'm pretty sure. So vertices, vertex buffer dot vertices size vertex count. I'm going to not do that. I'm gonna just assume that I need to go make my thing. Yeah, this is not gonna be 1-for-1 because we have a kind of a different way of doing this. Yeah, let's not do that. Who owns? I think we're making. Oh, whoops. I think we're already allocating our CPU version of the V buffer anyway. Is that right? Huh, I actually don't remember offhand where, because Because that would be in the draw frame, and that is actually getting blown away every time, right? It should. Well, because we're knitting a draw frame. That's a great question. Where is that? Where's that getting set? We zero it out here. I think it's just like the fact that because it's like here, and then this has the size in it, right? Because it's that big. Oh, but that's not the vertex buffer. Oh, shoot. Do I just not have one? Oh, I think I really have just been letting Direct3D own that the whole time, because I've just been managing the quad buffer. Oh, that's right. Oh. Oh, okay. Well, then I suppose I do need to go make this then. Which explains why I needed to make it here, right? Or where was it? I needed to make it here. Yeah. Well, that's fine. Okay, well, we will keep that then. Don't I have a macro for that. Max collider vertexes versus vertex count, max collider. Oh, no, we want max vertex count. Oh no, that is hard coded there. Yeah, that's one less magic number, right? Max quad count equals max entity count times, because now I have no idea why that's 16. Why is that 16? Huh. Who cares about max quad count? Is that arbitrary? Did I just assume that like an entity could have 16 quads? Alright, this is a magic number. So we will at least label it as such for now. Max collider versus yeah. Okay, we will just do that. Oh, and then we can do this now. Okay, cool. And then we have to actually go own the vertex buffer ourselves. Oh wait. Oh, yeah, you know what? Maybe we might not have to care about this, because I am like all my logic is just my code is already written so that I'm constructing the vertex buffer like in the render API basically already. So if there is a separate thingy, let's confirm what is going up in these next two calls. So game setup vertex buffer. Okay, this is like all the UVs, blah blah blah. Yeah, we have that code already. Okay, what does this one do? Because this actually is a okay. Yeah, look. So this is the thing we actually care about here. This is like where Metal is going to be getting its where Metal is going to be owning the vertex buffer, which is the part we need. Set up Apple vertex buffer. So does that get called? It just gets called this one time. So we will just take that directly. And then we don't need this. You know, we will just make it on the GPU or on like when we pass the quad buffer into the GPU stuff. Vertex buffer size equals times k, didn't like that. Oh, k command q new buffer with bytes. Oh, it does still need one. Okay. We still have to figure out this command Q stuff. Okay, well, so I guess I spoke too soon. We are gonna need this. What kind of type is this? This is gonna be just like a vertex array. V buffer. Okay. We don't want that. Yeah. We will new buffer. And then I think that's all. Okay. We're getting there. We're getting there. This is telling. Okay, yeah, because we want to be directly blitting this stuff from the one thing to the other. So that's fine. Okay, we're almost to the end of this main here. We're so close. We're so close. I think when we do get there, I think I do expect it to at least draw our clear color with and have the correct title. So I'm kind of excited to see that. That would be a big improvement over the black screen that doesn't do anything, because that would mean like we are actually our metal init stuff is good enough to kind of work. So this is some asterisk there, but that would actually be pretty huge. Okay. Oh god. Okay, so we are gonna need the shader now. Okay. Okay, well, we can do that. We can pull in the shader. So in Direct 3D land here, I kind of did it like awful inline like this, which is probably not how you want to do it. How does that actually get in there? Oh, so because you just are, it actually is just in memory already. So that's how you do it. So for this one, path for resource shaders, type metal lib. Did he tell it what shader file to be using anywhere above here? No, I don't think so. So how does it, am I just skipping ahead a couple steps? Bundle path for resource. Oh, is it just in there? Alright, I need to investigate on, forgive me for a moment while I take a look at his code. Is it in here? Oh. Shader is getting embedded in to the app bundle. And path for resource shaders. And I think if you're to look, yeah, there it is. So, but this is not a compiled shader. That is that's the file. New library with file. Well, can I just inline it here too? Because I don't know. This is something I know that is like I'm probably not doing right now. Because like with the way I have my I have things set up on with Direct 3D. I'm compiling the shaders every time I launch the game, which is probably not right. It's probably not what you want to be doing, because it's like why not just compile it the one time? Let's figure that out. When should I be pre-compiling shaders? Compiling them at game launch in D3D11 and metal. Also, how do. Okay, for shipping games, pre-compile your shaders. Yes. Okay. Oh, whoops. We don't want to do that. Okay. Alright. No startup compilation time. Oh, interesting. That could be a problem, couldn't it? Oh, my game might not work on anybody's computer that doesn't have like the Windows SDK on it. Or interesting. Well, that's good to know. Runtime compilation is useful for hot reload, shared. Yeah. You usually structure engine. Yeah, I'm sure you do, Mr. Chat GPT. Um. Hmm. 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 Well, we don't really have this. We don't really need to ship yet, but source to MetalLib. So what is? Why is there two steps here? Here's that air. Here's that MetalLib. Yeah. So this is kind of like what Ted is shipping. Is the shaders MetalLib. Um. Yeah. Right. Yep. Can instead do. Okay. So we can do that for now. Is there? I'm just not familiar enough with shaders. So, how can I make my shaders more cross-platform? And I'm gonna go grab some tea while that spits out some nonsense. Let's go check how the socks are doing. That will determine how much time we got left. Oh, they're still in the 6th. Oh shit. Oh, the Sox are winning right now. Oh crap. Good for them. That would be a first this season. Okay, cool. I have been told there is a there was a fight fight on the field right now. So that's fascinating. Well, Jesus. Oh Jesus. Did someone like invent this yet? Increasingly do from HLSL. Yeah. Yeah, it's just gonna be annoying. You know what? My shaders are like not complicated enough to care right now, and this is not a real problem yet. Until maybe I add a Vulkan renderer at some point, then it might be a problem. All right. Let's try this compile on the fly business. That would be nice. let's switch over to Claude. You know, we gotta cycle through these boys. New library with source. Shader metal compile at runtime. I'm gonna go to the bathroom too. Okay, so here we go. And this is exactly what we wanted. What? So let's do that. Let us do that. Yeah, we just want default compiler settings. All right, and let's go grab this shader here. Where did it go? It's in this one, and then like so. And then we will just grab the whole kit and caboodle here. Okay. Is this can I just like make it work, please, sir? Make it work. Oh. Is there like no way to just multi-line it? Blah blah. Okay, no. Can I multi? Cause I just want to do that. I don't want to do this bullshit. That's so annoying. Oh yes. Here we go. Here we go. See, it was that simple. Okay, cool. Cool. Oh, actually, is 14. And then we gotta go all the way down here. This one is 128, so 114. Why is that still not doing it? Oh, I have to do this? Okay. Okay, cool. Oh, we don't want that. Okay, cool beans. And we'll go actually rewrite that in a second. Any trailing space after no, we're good. We'll have that just the way it is. Oh, we have to grab this, and we need to pull all this stuff out into here. And then we want this thing. I meant this thing. I meant this thing. Okay. Why did? Oh. Metal device. Oh, it's this one actually. Shader library. Set up alpha blend for render pipeline color attachment. Now, what on earth could that be? Pixel art shader. Set up alpha blend for. Okay. Okay. We're just doing a bunch of fields. That's fine. We will just refactor that when it's done. Okay, cool. We've got the pixel art pipeline state. Oh, it just doesn't like that. That's fine. Okay, awesome. And then we need an instance buffer. So we just have to go make this memory too. Oh, we don't need this shader anymore. So that's actually pretty awesome. We're really closing in here. The walls are closing in. Oh, like this is not where we want to be. We want to be here. Instance uniforms buffer. Oh, okay. So we need to do this one And then we're so close, right? We're so close. So close. So close. Alright, we will just grab that whole darn thing. I'm not exactly sure what instance max is going to be, but we'll figure it out. Else. Oh, is there still an else preprocessor here? No. Okay, we're good. Am I missing the... I'm just missing that type too? When does this stop being metal view delegate? I think I went too far. Cause this is down to here. Oh, it's really just that part. Objective-C syntax like just confuses me to no end. I'm still not quite there, I don't think. Cannot find... Oh, and then I need this, because where is... Oh, why would he use MTK? That's fine. Why is... What's going on here? At interface, blah 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 blah. At property, blah 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 blah. Oh, oh, all of these are inside of that, I think. Is that correct? This is the custom metal view. Yeah, this delegate stuff is kind of annoying. Okay. Basically, we're just gonna get rid of all of that crap for now. Interface. Oh, method definition for configure metal not found. Where did I say it needs that? Oh, right there. So, and that is in here. Okay. And you know, we're going to rewrite all that delegate stuff. It's just not something I know really how to do off the top, but we'll just assume that's going to work. Okay, that kind of looks like it worked. Maybe. That's a big maybe. All right. Oh, okay. So what is going? Oh man, we're closing in on it, boys. We're closing in. All right. Oh, my tea. That's right. That'll help. Yeah, that is definitely going to be a little overbrewed, but we are in the thick of it. Okay, so all right, what is this instance buffer stuff? What exactly is going on here? And is this correct that is actually the last of like the init things that we need to implement? Oh, okay, well maybe this one. No, this is all game state stuff. I think that's gonna be it, right? Dispatch queue. I think that's gonna be it. Because again, you know, we are so not worrying about sound sound right now. So not worrying about that. I think that is going to be it. So we just have to do this. So what actually is this? Texture draw command instance buffer. This is uniforms. Oh, this was that thing with the vmin vmax. I'm a little confused, like what the difference is between this and the vbuffer. Like, do we really need this? I have no idea. I have no earthly clue. Here, that's probably a little better. I think I think I don't need it. I think I don't need to make this one. Let's see if we can get away with it, right? And we're gonna just we're this close, so I'm just gonna like comment out anything that is like magic DirectX stuff for now. Oh, whoops. We're gonna comment that out. We're gonna comment that out, and that, and that. Whoops. We will comment that whole thing out. We will comment that out. We'll comment this out. Comment that out. Oh my, yep. We are doing some degenerate stuff here to our perfectly nice code base. This is so sad. This is so sad. Oh Lord. Almost there. 3 more errors. Okay. Okay. Will that compile? Oh crap. Not quite. I'm surprised it alright, since we definitely don't want to write that buffer. We definitely do not want to write that one. Why is this not oh, those don't work still. I'm surprised Clang didn't tell me that. It probably couldn't figure it out because that is maybe some sort of I don't know, some OS specific compiler thingy. Why is that already there? It's weird. Okay, and then once more into memory. And then we're so close. We're so close, ladies and gentlemen. Come on. Undefined symbols for architecture ARM64. Anchor command. Game message file directory. Initial undefined. I don't think I have another main in here, right? Oh, this is so mad at me. Oh, why is this like so green now? Okay, something's weird. It doesn't like that big string literal in there, but that's fine. Who would care that my entry point is... Oh, this would care that my entry point is something stupid. Yes, it would. Yes, it would. We want this one. We want that one, indeed. Ahaha. Oh ho. One warning generated. Pragma wants outside header. Oh, am I just not allowed to have that in here? It's fine. Oh. Oh, snap. Oh, it compiled. Okay, didn't like that. didn't like that. Alright, let's not try to run it through Xcode yet. We will go try to run it just this way. Yeah, this is the one we just did. Oh. Oh no. Oh no. What did it do? Thread crashed. Byte right translation fault. Ooh, interesting. Did not like something we did. Did not like something. What is going on here? Why did this read-only portion of libraries? How did this end up with so much size? So it looks like something must have null pointered, right? Something must have null pointered. Oh, you know what? It's most certainly all of the memory we're trying to allocate, because there is no we didn't implement the allocator. That's definitely it. I mean this one. Oh yeah. Let's not even try to do that, right? And then we just need to hard code window how do I nmap? Because this is gonna get mad at me here, because these are map. Here we go. Let's do that. Mem dot window equals okay, and then we'll just set all the crap we want to width 1280. okay, then window clear color equals E4. O equals, let's just do like color red so we can just tell. I think that was the only things we wanted to be setting. Oh, I did it again. Yeah, that won't still not work probably. Where's our Finder window? I closed it. Please be red. Oh no. Oh no. Triggered by thread 0. Sig abort. Abort trap. This is where it would be nice to be able to debug into this thing, wouldn't it? I mean, we may as well just try to figure that out now, right? Let's... Yeah, let's just like feed that whole thing into... Oh, god damn it. Fuck. How do I... Fuck me. I hate Mac. How do I get back to... come on. How do I explode everything? I need to be... Oh, Jesus. I made it so much worse. Okay, here we go. Copy. Paste. Excellent. Validate with dice. New render pipeline state with descriptor. You're passing nil for the error parameter. Descriptors are invalid. Why didn't it like that? Oh, we don't want to do that. Okay, cool. That totally is not right, but I kind of doubt that was causing the crash, right? Oh, I mean, I let it compile this whole thing, right? Let's see. Oh, here we go. So metal pipeline descriptor. In main plus 1672 user shader factory. Oh, did it not find these? Oh, that could be a problem. Pixel art. Did it not load that correctly? Oh, did it where's our code? Now I'm confused. I think maybe now it's because I just created an unhandled exception, right? Seek abort. Vertex descriptor. Yeah, let's ignore that. Let's let's assert. That would be better than this bullshit, wouldn't it? Let's assert. Why is it not letting me NS assert? It's only valid in oh, okay. Alright, let's do that. And then where else can we error on this? Right here. Okay, let's try that now. Does it not tell me my asserts? That's a little irritating. Main plus handle failure function line description. Yeah, it is hitting an assert, but I just can't tell which one here. Just reading this dump. I think we really should be doing this in Visual Studio, right? So how shall we do that? Why does this not work? Failed to create archivable representation for that. Alright, yeah, why don't we delete this Xcode proj and start again with that. Let's do a new project. We want one that is totally blank, other empty, external build system. Let's just do empty. Oops. Okay. We will create the folder. Actually, I'll just call it Xcode. Okie dokie. And then I think what we wanted to do, debug executable. We want to debug our executable. Yes. Okay. Launch automatically. Yeah. Why not? Why not? Okay, shall we try that? Shall we try? Oh, I fucking Can I? Yeah, let's just do that. We will try to just debug this. Want those things. Elementary version. Oh, we got some red. Shader compile failed. Oh. File not found. Common shader types. Haha. Well, that's good. We found something. We found something, right? Can't find your app bundle headers. Why? Oh, Ted has some more junk in here that is... Oh, this is not just a single file shader. Okay, alright. Let's refer index. Can I just like type def? Can I just like do this? Oh, no. Okay, and then we can dump that here. And then we can get rid of these. And bada bing. Stop. Oh. Unknown type. uint 32. Oh. Okay. Yes, yes. Oh, my beautiful red rectangle. Oh, it is so majestic. Oh, that's incredible. Oh, oh. That's just beautiful there. That is so beautiful. Oh my god, look at that nice, amazing red rectangle. That is so huge. That is so unbelievably huge. Holy smokes. I will pack it up. Pack it up, boys. That's the end of the road here. We got the rectangle. We did that shit. Um damn son. Damn son indeed. Well, can I open up the symbols in here? Uh because that's what we kind of need to do is like debug into this thing too. That's a lot of processes. How do I how do I just like open a file? Can I just open a file and it will work? Do you think? Do you think it will be like that simple? Oh shit. No, of course not. How oh, that's kind of annoying. Oh, I don't have a handle for that. Go away. Kill it. Alright, here we go. Alright, shall we fix that target version just so it lines up? Let's try run that. Apple deployment target version 10.14 does not match. Okay. Xcode debug executable. I pressed debug executable in Xcode with my game. How do I load the symbols and open my source files in debugger? While that stews, I will brew some tea. Stew and brew. And I've got to go to the bathroom too. Okay. Debug navigator. Debug. Breakpoint. Debug navigator. Okay. We've got like 1,000,000 FPS right now, so that's pretty good, I would say. That seems like pretty good. No. Oh, search scope. Can I open this? Oh, here. Oh no, this is the Git. Yeah, that's not what we want. Click thread 0 and click the frame in your game binary. Okay. Thread 0. How? What? If it paused, or if source map, right click a frame in the stack. How do I see that? Console. Add files to what the hell do I do here? Oh, yeah, we can try pause it. Oh. Did that work? Oh, here we go. We paused, and then... here we go. Here we go. This is the disassembly. Right? So now we need to... How do we load the source? Debug workflow. Navigate to source file. Add files. Okay, maybe it just doesn't have it. How do I think I have to edit the scheme. Here, oh, let's close out of this because that's gonna drive me crazy. I think I like edit the scheme, and then yeah, I need to point this at my at my symbols. It's kind of irritating. It couldn't just find it when it was right next to it. How LLDB init file? Right click frame and say out files debug session. It's like I don't see a spot in here to do that. If we pause again, show library info. See. We are just like totally just like randomly clicking around here. Right click a frame in the stack. Add to the thingy. Yeah, because we're like just looking at freaking this. How do I load the symbols? I'm building the symbol. I know I'm building the symbols. They're right here. Maybe it doesn't like being in the app bundle, but we should be doing this in the app bundle, right? Because there's gonna be enough AppKit crap that is gonna try to load from the app bundle. Okay, let's see. Target. No, we are building it. So, what did this like make a new Xcode proj for me? Oh, it's not doing that. Let's add target. No, that's not what we want. Do a new scheme. Should call it debug. Okay, and here we go. We want our executable will be this bad boy right here. Okay, that starts our thing now, which is cool. So debug workflow. Oh, here we go. Okay, so it couldn't find it. Is this auto-saving my project? I really hope so. Kind of looks like it is, so that's good. Have my own build system. I have game.app and game executable and game.using in my build folder. I made a blank proj and created a scheme that launches game.app for debugging. I have no symbols though. Yeah, I had, okay. When, run, okay, let's, so we want, where's the scheme? Okay, the scheme. Run info. Oh, right. Add path remapping. And this is a little irritating here. No, we don't want to do that. We don't want to have it build anything. So into Xcode project now. Okay, so I suppose we can do this dragging business. Reference files, place. Okay. And then pause now. Yeah, that still does not look like it's got symbols, does it? Does it at all? Oh, where did my console go? God damn it. How do I get that back? There we go. Unable to. Oh, do I need to make this have input? Do I need to do that thing? This is like way more complicated than it needs to be. You should be able to just frickin' do something, dude. You should do relative to project, I think. Want that, I think. Okay, so now we can theoretically do this. Sorry if I had to move this thing. That do anything? No. This is probably not the right console. How do I get the LLDB console? Wow, this is like way more irritating than it needs to be, isn't it? Oh, here we go. Okay, here we go. Oh, okay. Okay, so it found... Show your binary with UUID. Yes, we did that. Oh. One match found in there. Inside of that. But it doesn't look... It found the Yeah, I don't think that worked. Okay. Oh, okay. Do you think that will work now? Which thread has my shit in it? Where's the thread? Where's the real thread? God, this is quite annoying. Where is my thing? Oh, here we go. Oh, awesome. Awesome, it loaded the symbols. Oh, that is badass. Okay, let's see if we can break somewhere. Oh, it worked. Yes, we can break. Oh my god. Oh, thank god. Thank god. All right. Why doesn't this work though? That's what I want to know. How do I? Excuse me. Is there a target here somewhere that I'm not? Something I'm missing. Hmm. What is the deal? Build settings. Oh, okay. Manage scheme. Edit. Does that matter? I don't think it does. Kind of appears to not matter. So, we choose not to care. We choose not to care. Okay. So if I close this out, we build, right? Actually, we'll do one better. We will totally rebuild. If I run, oh crap. Didn't like that. Open, shell script to open my debug Xcode project. Oh, yeah, that would be pretty obvious. Dot slash. Oh, we want the current working directory. I always hate doing this. And script dir slash. Oh. Slash xcode slash xcode.xproj, right? I think that's what it's called, xcode proj. Okay, cool. And then we start, and then will it work? Oh, and it breaks on the right thing. Oh, that's incredible. That's incredible. It is a little annoying that how do I open up like the second file? That's gonna be a problem. Um, well, that's pretty good that that works, right? We're pretty happy with that. So let's just stage everything, and then we are going to commit that. Red window with metal. Xcode is loading symbols. It's pretty good. It's loading symbols, which means I can actually debug around and like actually do stuff. But it does seem like it's not quite right here. Oh. Oh, did we fix it? No. .26.5. Still saying 1014 for some reason. Oh, here we go. Here are the settings. So we can add one here, I think. Right? Uh um we would want let's try that. You know what? I kind of don't care. Okay, I lied. I kind of do care because this is kind of pissing me off. Set it as an environment variable? Are you for real? Okay. It still doesn't like that one. That's so stupid. That's so dumb. Well, this one we can change, right? I think we figure out that one works. Okay, so now it's just this one that's broken. no target in the targets section. Game binary itself. Now, this is my thing, dude. I don't know. It still thinks it's 10:14, so that's like, I don't know where this 10:14 crap is coming. It appears to not be doing anything, so let's just give up trying to solve this problem, I guess. Okay. All right. What do I really want? How can I open my whole source directory in the Xcode debug projects to breakpoints in more files? Just drag your entire thing into the project navigator. Okay, we can do that. And then it just will work, obviously. It just works. Okay, no. Okay. And does this have our breakpoint? This does have our breakpoint. Oh, looky there. If I add another breakpoint there and start it, will it work? It does. It did not work. It did not work at all. The hell? Why didn't that work? Why didn't that work? Is this like stale now, this one? Oh, man, why is it so much more inconvenient to do this on Mac? It's ridiculous. I'm setting breakpoints, but it's not stopping on them. Okay, yeah, we can try to pause this, and then in the LLDB console, you can see yeah, it really looks like it is not have the thing. Yeah, I'm highly suspecting that the UUID changed from this thing. Slash. Then if I look up main, it should find like the actual one, right? I would think. kinda doesn't look like it. Did I scroll past? Oh, okay, yeah, now we can find it. Now we can find it. So I'm guessing the UUID of the DISM changed. Uh um make sure your build script also regenerates the DISM place. Okay. Um unable to open object file. Hmm. Let's close that and then try again. Alright, I think unfortunately we're gonna have to call that for tonight. I've got to go do some fun stuff now. So thank you all very much for watching. Awesome progress today. Did a lot of great stuff. And next time I see you, this Mac port's gonna be like there. 100%. It's gonna be awesome. Hopefully we'll be back to doing some fun game design stuff. There might be a couple of fun streams here and there, but unlikely. But keep posted. Thank you all for watching.